Now, so like when you look at the trend for, you select this series here, okay, and you click on it. That, let me click on the brown one down there. So when we click on the series, you see it leads us to the regression. It leads us to the regression data here. Once we click on it, it gives us the trend from regression analysis. Right? Good. And okay. So clearly the broken line, like I said, is the series for the regression trend, okay, which was estimated. And just under the regression trend, you see another one, a brown one, okay. When we select on that, there's a series just below it, okay, the ash broken line. Or better still, you let me take the regression series off, then we get a true picture. So this is for the moving average. Okay, this is the moving average trend line. And this pattern you are seeing here is for the observed data, the true data itself. That is it. So when you select it, you get the actual data. You see the moving average trend and the exponential. The exponential is far away from the main data because there was what? A pattern or a trend in the series, okay? An upward trend in the series. When you apply the exponential, okay, it's giving us a very bad result. But once again, you can adjust your alpha value, okay? So this time alpha value is 0.2. So you may want to use a bigger alpha value, maybe 0.5 or 0.6, and then see the outcome, okay, of the exponential model, okay? But clearly we can see that in this case, the moving average and the regression techniques, okay, give us the best, okay, trend lines for fitting the observed data, okay? Good. Now moving on, today we want to look at, as a first step, decomposing or explaining the various factors, all 4 factors within the given time series. We have to estimate a trend, which we have looked at. Now, the next thing we are coming to look at is how do we also sort out the seasonal, okay, effect or the seasonal, okay, variation within the data. How is that computation made? And as we do that, we'll be swapping between R and PowerPoint slide, okay, so that we can really see the picture, okay, how this thing really works, okay. We'll do the computation, and after that we'll also look at the decomposition in R, okay, to see how it really works. Okay, so let's begin.
Yeah, so you're all welcome to today's class. Last week we began with,
let me move forward a bit,
of a time series. Okay, then again we looked at how to identify the various components of the time series and how to extract the trend in the data which is relevant for forecasting purposes, okay, using both the moving average technique as well as the regression model and exponential smoothing techniques. Okay, today we want to continue from there, and as our objectives, we are looking at how to deseasonalize data. Okay. So, for example, unemployment and employment data are often seasonally adjusted. Okay, so that the actual change in unemployment and employment can be seen. Okay, because there are seasons where you have students still in school, and there are seasons where graduates will graduate and from the various universities and schools and will be at home. So we need to adjust, okay, and try to within the specified season so that we can really make room for very good prediction of employment or unemployment. Good. Okay, that's another example. Now, in estimating your seasonalized data, usually calculate what we call as a seasonal indices. Okay, and then given the actual data or the actual results, we can estimate our seasonalized data as your actual results, which is your Y, okay, divided by the seasonal index times 100. That is when you are making use of a multiplicative assumption or a multiplicative model, okay? And I told you last week that when you are making use of a multiplicative model, then you as a modeler or as a statistician is assuming that there is interaction between what? The variables. Okay. So moving on, just a minute, please. So we are, another point here, we're saying that usually government statistics are often represented as seasonally adjusted data, so that a true indication of the trend is what is revealed. Okay, trying to adjust for seasonality within the various quarters, maybe quarter 1, quarter 2, quarter 3, and quarter 4. We want to take the effects of the various seasons from the data so we can have what? A true estimation, okay, of the trend. So now moving on, we're saying, so in summary, we are saying to ensure a reasonable, accurate forecast, okay, then individual components of time series must be separated out and examined carefully. And to decompose, we have to determine first the trend, which we did in last week's class, okay, then based on either an additive or multiplicative model or assumption, we can find what seasonality, cyclical or random patterns, okay? And these are the models we have. We have Y, that is your observed data, okay, is equals to the trend plus some kind of seasonality, cyclic, and what? Random, or what we call as the irregular pattern, okay? So this is what we are basically trying to say. If the data is moving, okay, that way, so we have this time series data. What we are saying is that within this data here, okay, first we have the trend, okay, then beyond the trend, you see, Y, this graph here is your Y. Then the trend is your T. Okay. Now, Y is not equal to the trend. Y is equal to the trend plus seasonality, because there are deviations from the trend to Y. Okay. So the remaining deviation is explained by seasonality, cyclical, okay, variations, and irregularity. Okay. And what we are saying is most of the times what you have within the data may be due to seasonality, okay, and trends most of times, okay, good. So which basically brings us down to a model of Y equals to T plus what? Plus seasonal type of data, okay? So if we're looking for trend is basically equal to the observed data minus what? The seasonalized, okay, index or the seasonalized variation. That will give you the trend. The same way, if we're looking for what? the seasonalized variation is equal to the observed data minus the trend, okay, in an additive model, right? But in a multiplicative model, it's going to be okay. So in a multiplicative model, we are saying cyclical irregular are not really frequent, okay, within our data set. So we are looking at this model here, which means our trend will be given as observed, okay, divided by what? The seasonal, okay, index, or seasonal index will be given by observed data over what? Over the trend, okay, good. That is what this assumption brings to us. And for multiplicative model, we usually must multiply it, okay, and then put the index in terms of 100%. So we multiply by 100, okay, so you take note of that. Good. Now, moving on, today we'll be doing a lot of calculations, so you should have your calculators at your end. Good. So that is basically what I've explained. So for seasonal components, your S is equal to Y minus T. That is if we are assuming additive model. And then for multiplicative model, seasonality is Y minus what? T, okay? Good. Then in the next stage, after you've estimated the seasonality or the seasonal variations, okay, you need to find the average seasonal variation for each quarter, okay? So first we are going to find the seasonal variations. Then based on the seasonal variation, we'll arrange them in quarters and find the average seasonal variation for each quarter, okay? Then based on the average seasonal variation for each quarter, we can now make adjustments. We also need to make adjustments when there are elements of irregularity, okay, within the data. Good. So we have a data at hand. We are saying quarterly sales of vehicles in 1,000 Ghana cedi are provided in the table. Okay, so for 3 consistent years or conservative years, and we have so this is it for 3 years. That's year 1. And within year 1, we have it on quarterly basis. Okay, so quarter 1, 2, 3, 4, 5. But the data is, you just align them as period 1 to 12. These are the sales. Don't forget the sales are in 1,000 Ghana cedi. So what we are seeing here is 80,000 Ghana cedi. Okay, just for simplicity, it's been kept as 80,000. Good. So the first thing we said we have to do is, before we can decompose or we can deseasonalize, okay, try and take away the seasonality from this data, okay? Good. Of course, when it comes to vehicle sales, there is some amount of seasonality in there. People will want to be shipping a lot of goods, maybe during what, a particular season. So we need to isolate the seasonal effects from Y so that we can determine the true trend in the sales of vehicles. That's what we are saying. So we are supposed to determine the trend using regression model and also to find the deseasonalized trend. Okay, good. So moving on, given this data, we are going to make use of the regression model, okay, for estimating the trend. Okay, so we have our beta is equals to that, and alpha or A equals to this. Good, and then estimating from there, we have this model that Y, okay, Y is equals to 81.68 plus 5.19x. Okay, so please put down this model, write this model down from your end. You have to work.
Take note of the model, okay? This is the model we estimated from class last week. And we are going to work on the same data from last week class with this model, okay? So you let the video run, I'll come in.
Do the calculation at your end. So put the model down. We are going to use it for calculation. So in the next slide, we are going to estimate the trend using this equation, the function we've just estimated here. So that is it. We have the trend values here. Okay, so in the model, I think the model was, let me write that down somewhere here. So we have, I put it in the corner somewhere here. So 81.68 plus 5.19x, okay, equals to y. Okay. So we're going to estimate the trend given the equation, so which means that if x equals to 1 for period 1, these are the calculation for the regression model. Like we saw in class last week, you first of all find x times y, okay, this will be it. Then after that, you find s squared and then put it in the formula. You said beta is equals to n summation xy minus summation x and summation y all over what? N summation x squared minus summation x all squared, okay? Cool. So you do those computation, then the trend will be based on the model at this point. Okay, so let's estimate the trend when x equals to 1. We have 81.68 plus 5.19, which gives us 86.67. So I'll need you to do the estimation when x equals to 4, 5, 6, 7, and the rest. So just estimate it for me and then send it to me through the chat.
In essence, what we are saying here is you find the trend values, okay, like we did last week. And as I explained today, using the model, the model we just looked at below here. So all these values are calculated. So x will be 1 in this model. Use y is equal to what? 81 points. Is it 168 or so 68? Okay, plus 5.19. Then x is 1. The first period will be x equals to 1. You put it in there, okay, to get this first value here, which will give you 86.67. Then when you put x equals to 2, you get it. So it's just a regression prediction. Once you predict, you get all the trend values here. After you've obtained your trend values, the next thing you should do is to find, okay, we are using an additive model to estimate or to decompose. So what you do is you subtract the trend value from the observed value. The observed value is a real, the data of the sales data, okay? So you subtract the forecasted or the estimated values here, the trend values, which is 86.67 from 83. Once you do that, you get negative 3.8. Repeat that for all values. Subtract 92.06 from 91. you get negative 1.06. Subtract 97.25 from 95, you get negative 2.5. So these values, just put the values of x into the regression, okay, formula to find all the trend values. That's what I'm saying. And after that, you subtract the trend value, the corresponding trend values from the observed values to get, okay, the estimation for the seasonal variations. Okay, if there are any questions on this point, you can ask before we move to the next thing. Any questions on this point? If there's any question on this point, please bring it up before we move on. Yeah, so I'll fast forward a bit for the sake of time. Yeah, so you can see that we are going to find seasonal variation, but take note, we are using additive model here. So seasonal variation is going to be your observed data y minus the trend we just estimated. So that will be 83 minus 86.67. So 83 minus 86.67. So do that calculation for me. Okay, so you can see from
yes, I'm still waiting for your answer.
We have the regression values. Okay, just subtract them from the sales values, then you get your seasonal variations here. Okay, now in the next step, we are going to rearrange all these values. That's the negative, the seasonal values. Take note of the first three. We are going to rearrange them in the various quarters. So for the first year and for the first quarter, you will have negative 3.86. First year, second quarter will be negative 1.06. First year, third quarter will be this. First year, fourth quarter will come. Okay, so we are going to rearrange them